Hello, everyone. Thanks for joining, and welcome to another session of our Day One and Beyond series, where we take you through various topics and activities related to building out on Oracle Cloud. Our today's session is Regain Control of Your Monitoring Alarms with Stack Monitoring, where we will cover how to standardize and maintain alarm definitions at scale with Stack Monitoring's monitoring templates. I'd like to introduce Aaron and Anna as the main presenters. And with that, I will hand it over to you, Aaron.
All right. Well, happy Monday, everyone. I am Aaron Reimel, and I have here with me Anna McCollum. We're product managers with Oracle's Observability and Management Group. Today, we're going to talk about how to regain control of your monitoring alarms with OCI Stack Monitoring. For our agenda today, we will begin by reviewing the Stack Monitoring service. Next, we will review the basics of an alarm definition and how alarm rules are manually created today. Then we'll jump into the fun stuff, monitoring templates and maintenance windows, along with some demonstrations. Anna, before we go too deep into Stack Monitoring, can you provide us some background into Oracle's observability and management strategy?
Sure, Aaron. Stack Monitoring is part of Oracle's Observability and Management Platform. Our Observability and Management Platform, or we call O&M for short, it's a cloud-native platform bringing together all telemetry, metrics, events, logs, traces, SQL, for monitoring and analysis. Our solution consists of integrated services, including application performance monitoring, stack monitoring, logging analytics, database management, OS management, and Ops Insights that collectively can monitor your resources across hybrid and multi-cloud environments. In this session, we will focus on stack monitoring. Stack monitoring is the service that provides discovery and monitoring of applications and their underlying infrastructure stack. With stack monitoring, you can quickly get answers to essential monitoring questions, such as, well, first, what's running in my environment? Is everything up and running? Do I have any performance degradations? Am I running out of CPU, memory, or storage? What's happening across the stack? Is the performance of one resource in the application stack impacting the entire application? Stack monitoring supports heterogeneous environments with special focus on Oracle apps and technology.
So, Anna, when I start thinking about stack monitoring, I think of it sort of like your general practitioner, right? Whenever I go to the doctor, the first thing that they do when I step in the doctor's office is start collecting my vital signs, right? Whether or not I like it, they're going to tell me what my weight is, what my blood pressure is, how, the fact that I'm probably shrinking and not getting any taller at this point. They're going to go through and just understand the current status of my person as I'm presenting at that point in time. And in many ways, I think of stack monitoring in the same way. It's, what is up in your environment? What's your CPU? What's your memory? What's your heap utilization? Do you have any stuck threads? It's just that basic that essential set of questions to know about the current status of your application. And then you'd spoken about APM and DBM and OPSI, et cetera, earlier. And then I think of stack monitoring as kind of that initial focus. And then you start jumping in, you see a problem and you start diving in deeper to APM and doing trace transactions, doing those synthetic tests, et cetera.
That's a really good analogy, Aaron. I like that. So with that analogy, let me get into the more specifics into some of the key features in stack monitoring. In stack monitoring, we start with discovery, and you can easily set up discovery and monitoring in just a few minutes. You can leverage our single-click discovery UI that discovers a complete application stack and its topology. We have native support for applications, including eBusiness Suite and PeopleSoft, application stack technologies that include WebLogic Server, SOA, OHS, Tomcat, just to name a few. We also monitor Oracle databases and SQL Server and other database technologies. Our host monitoring includes support for Linux, Windows, and Solaris. Then after discovery, you can immediately begin monitoring. We provide a curated set of metrics for each of these resource types, and we have built-in monitoring UI to allow you to quickly answer those essential monitoring questions. For example, our built-in enterprise summary provides an overview of health and open alarms, identifies resource outages and performance outliers. Then as you're troubleshooting, you can quickly change any performance charts, review any metric, or any related resource that could be contributing to performance issues. Another key monitoring UR is our stack view. Stack views enable quick assessment of application health, such as an e-business suite or a PeopleSoft application, by showing that application's key load and response metrics, along with the performance and utilization of the underlying app server, database, and host, all in a single view. Using machine learning, stack monitoring can learn performance baselines and auto-detect anomalies that are automatically shown in performance charts. You can also extend monitoring by adding your own custom metrics using metric extensions, or by creating new resource types really easily from an app's process signatures or from any type of infrastructure that exposes metrics through Prometheus endpoints. Finally, an alarm or alarms are an important part of monitoring, and we do offer best practice recommendations for alarm rules for the resources that we support. So when the alarms do trigger, you can drill down to find out details, such as the latest value of the metric in the alarm, so you have an understanding of how imminent the issue is. Okay, Aaron, that was a super quick rundown of features in stack monitoring, but I think our audience is here to understand how we can help with their alarm setup and their alarm management. So do you want to discuss how stack monitoring can help them with those tasks?
Hey, thanks, Anna. So first, what I think we ought to do is just understand the basics of alarm rule definitions, how those are created today, and then how we've simplified this process greatly. So an alarm rule definition. All status and performance metrics are stored in OCI monitoring, which is the service used to generate alarms. When creating alarm rules to generate alarms, it's important to first understand the metric namespace and resource group associated with the metrics for your resource types. For example, to find host metrics, you would use Oracle App Management namespace and the resource group of host. Or to find WebLogic server metrics, again, we're going to use Oracle App Management namespace, but this time the resource group of WebLogic J2E server. Now, Oracle database metrics, those are stored in Oracle OCI database namespace. But if it's a listener, ASM, or other cluster Oracle database resource types, it's going to be in the Oracle OCI database cluster namespace with the corresponding resource groups. We've got a whole list of these in our documentation and the namespaces and the resource groups. So if you want to know more, that's where you can go. So knowing that, let's walk through the process of manually creating an alarm. This will help understand what stack monitoring has done as far as monitoring templates. In the first part of this rule, you'll start off, you specify an alarm name. Again, our recommendation is to describe what the alarm is all about. The alarm name is ultimately what shows up in your list of open alarms. So for example, if we want to create an alarm rule for WebLogic server's heap utilization, we'd specify an appropriate name like high JVM heap usage. And for the alarm summary, we offer a quick definition that includes a link to your controlled work instructions. Being in production management for almost 2 decades, having that little, and I'll talk about this more as we go along, but I can't hound on this enough. Give your engineers what they need to be able to make timely decisions. Help lead them to the controlled work instructions right from your alarm message. In the next part of the alarm rule, choose the compartment where the resource resides. Next, choose the appropriate metric namespace, right? We discussed WebLogic server earlier, and that's in the Oracle App Management namespace and the resource group WebLogic J2E server. Now let's select the metric JVM memory utilization. And for the and then the next field is interval, and the interval needs to be at least the same value as the metric collection interval. And what I mean here is, if you have a metric that's collected, let's say every 5 minutes, you can't set that to 1 minute. Otherwise, you're going to start to see alarms clear and then refire over and over again. To find out about metric collection intervals for each metric, all of that's kept in our documentation. For statistics here, we've left it as mean. That's the default. And this So this metric is specific to heap utilization, and as such, we've chosen dimension name of type and a value of heap, which means we're specifically interested in monitoring heap utilization itself, not all memory utilization. The next step is to define the alarm thresholds in the alarm body. In this group, we wanted to fire a warning alarm if utilization is at 70% and critical at 90%. We'll set the operator to greater than and a value of 70, and we want this alarm to fire immediately, so we're going to have a trigger delay of 1 minute. And then we select the severity of warning. For the alarm body, we recommend providing that link to your controlled work instructions, right, on how to resolve that alarm. And make sure that it's, following a peer-reviewed kind of run book of steps, right? The whole definition of how to resolve that problem. For critical, we're going to do all the same things that we just set out for warning, but this time we're going to put the value of 90, and instead of warning, we're going to set it as critical. Now, at the bottom of the alarm rule, we choose the appropriate notification type. So here we're going to do a message format. We're going to update the message grouping to split notification, which means if you have 2 WebLogic servers with high heap utilization, you'll receive 2 alarm notifications. And finally, we'll select to have the notification repeat every 5 minutes. So, it's fantastic that alarm rule definition allows for so much customization.
Yep, that's certainly right, Aaron. Do you have other examples of alarm rule definitions?
So here's a sample list of our recommended alarm rules. Now, what I want you to think about is that entire process we've just outlined. Imagine creating that individual alarm rules for even a subset of alarms of a subset of resources that you have, right? All of those availability, every host, every WebLogic server, every Oracle database, every listener, every ASM, every cluster, you would have to go in and set up individual alarm rules on every one of those resource types. And that's just for availability, much less file system monitoring, table space utilization, memory utilization, CPU, you name it, right?
Wow, that could be really a daunting task, Aaron. Now that you've outlined all the different things that you need to do for just one alarm rule, right? Multiply that by many.
A lot. Multiply it by a lot. So that's where the beauty comes in with monitoring templates. One essential monitoring task is to just simply set up alarms. And currently, setting up alarm rules is done on a per metric basis. Over time, it can become a challenge to manage all of these individual alarm rules across different metrics, across different resource types. It's super hard to try and answer basic questions like, what alarm thresholds do I have set up for my hosts, or my database systems, or my EBS application? It's hard to answer this question because you have to look at individual alarm rules, since there isn't a way to just see these conditions all together. In monitoring templates, we address these questions. We provide a resource-oriented approach to setting up alarms. You specify the resources, for example, EBS, and its components like WebLogic, database, hosts, concurrent manager, you name it. And you also supply all the alarm conditions for these resources in a single place. So you know exactly what alarm thresholds you have across your app and infrastructure. If you need to review alarm settings or change thresholds for your EBS app, there's a single place to do this using templates. Once you define your monitoring template, we'll take care of creating all of those necessary alarm rules within OCI monitoring that are used to evaluate and generate alarms. Now let's circle back. What that means is you go into the monitoring template and you define these. You either use our Oracle certified templates, which we'll talk about in a second, or you define it yourself. And Stack Monitoring will make all those calls to OCI monitoring to go create and standardize that list for you. You can define monitoring templates for your production hosts, your production databases, or even custom resource types that you add. Now, like I said, we'll provide predefined monitoring templates with our Oracle recommended thresholds. Monitoring templates simplify and standardize monitoring by including all of these necessary alarm rule definitions to holistically monitor nearly any application or individual resource type. They're completely customizable, allowing you to set the evaluation interval, the statistic like the mean, the max, min, etc., operator, and both the warning and critical thresholds. Another helpful feature is customizing the alarm body. Remember, I'm gonna keep harping on this. When defining alarm body, give that link that navigates your engineers to those controlled work instructions, but you can put it right there in the monitoring template. And soon, Stack Monitoring will enhance our out-of-the-box alarm message to include a link directly back to the resources homepage in Stack Monitoring. It's going to help reduce time to resolution by removing the need to manually navigate to the resource to troubleshoot. And when creating a monitoring template, leverage the Oracle Certified Monitoring Template to help you get started quickly. Oracle certified templates provide an out-of-the-box set of metrics and thresholds that provide a great starting place when monitoring a new application. And these templates are available for all of the out-of-the-box resource types. You can clone and modify each of these templates to meet your unique monitoring requirements. For example, you can create a template that includes several resource types to holistically monitor a resource such as WebLogic. And the template could include WebLogic servers, WebLogic clusters, hosts, and even load balancers. Using these Oracle certified templates as a starting point, add or remove metrics, adjust the warning and critical thresholds, and customize the collection intervals. Like, does your site have you created custom metrics using metric extensions? Then put the metric extension in your monitoring template. Don't forget to create a custom alarm body with that link back to your controlled work instructions. And soon, like I said, we'll embed that link in there to take you right to that Stack Monitoring resource. So here is a portion of a small e-business suite topology. Now, imagine the complexity of creating alarm rules for every single resource in this list. Now, while this is really specific to EBS, clearly, the same is true for nearly any application. But since this is an out-of-the-box resource type, Stack Monitoring provides an Oracle-certified template that includes our best practice for monitoring this entire application stack. Now let's see a demonstration on how to create a monitoring template. So this is a pre-recorded demonstration of a monitoring template to help you understand the process of getting this created.
From the monitoring templates page, by default, all available templates are shown. This includes the Oracle certified and your customized and cloned templates. If you wish to only view the templates that you and your organization has created, simply deselect Include Oracle Certified Templates. Additionally, monitoring templates can be further filtered, for example, by status, on whether or not the template has been applied or not applied or maybe partially applied. Maybe you want to search by resource type, such as Apache Tomcat here or host. And lastly, if you wish to show only templates with a specific tag, you can filter by tags as well. Let's take a closer look at an Oracle certified monitoring template. This is an example of an Oracle certified monitoring template for WebLogic Server. Here we can see the resource type of Oracle WebLogic Server, and it has 7 alarm conditions. For example, monitoring status, also known as availability, memory utilization, and web request processing time, to name a few. Each of these conditions has its interval, operator, warning, and critical thresholds already pre-populated. Clicking a metric name will invoke a slide out that provides the alarm rule definition. The information shown here is in the same format of how it looks in OCI monitoring to provide you that consistent look and feel. Now that we understand the overall layout of a monitoring template UI, let's clone an Oracle certified host template to meet our unique business requirement. We will begin by providing a name and a description. Remember to always provide meaningful information to help reduce confusion of which template is for what purpose. In this example here, we are going to build a host template specific to monitoring an Oracle database host. When creating and cloning a monitoring templates can be applied either at the resource type or specific resources. For example, if we were to click individual resources and add our resource, Stack Monitoring will provide a list of all the available resources that have been discovered. Stack Monitoring will provide a list of all the available resource types. For example, EBS. Here we can see that there are specific templates for an EBS cluster or EBS host or EBS non-container DB. For this example, we're just going to keep it simple and add host. Each metric alarm condition can be customized. So let's take a closer look at customizing this process. Once again, this view is consistent with how an alarm definition is created inside of OCI monitoring, with only a slight change. Instead of selecting a resource group, Stack Monitoring has instead placed the focus on the resource type itself. Now, in this example, let's update the warning and critical thresholds to catch the CPU spike. And you see, as you adjust the warning and critical thresholds, the lines will change to help you gauge on when you could have caught a specific incident. So here we'll say 20%, which we clearly know is really low. And how about 35? That's it, pretty simple. Since this template will monitor production Oracle database hosts, let's define an alarm condition to monitor both root and the UO1 file systems independently. To do so, we'll get started with our file system utilization here. Click Edit. This is where we start differentiating. Click the file system name, and for the value, we will choose root. And we'll update this to 70 and 80% with a 1-minute trigger delay. Okay, with all the fields completed, we can now update the alarm condition. But before we do so, let's take a moment to look at the alarm body. The alarm body settings allow you to place a specific link to your controlled work instructions that address the metric that is firing. For example, you could define a warning and critical message with a link directly to your troubleshooting steps on how to resolve a root file system that's filling up. So we've added a condition to monitor our root file system. Let's now add a condition to monitor a UO1 file system. Select host. This is automatically chosen for us. For our metric, we'll choose file system utilization. Our interval will again be 15 minutes after we add that. Our interval will be 15 minutes with a statistic of mean. Now this time, instead of choosing the root file system, we'll choose UO1. The operator will once again be greater than, and this time we're going to do 80 and 90% with a 1 minute trigger delay. With all the alarm conditions defined, the next step is to define the destination. We'll take the default for notifications, and we'll select a topic that notifies the on-call DL or database team, etc. When creating a monitoring template, it is best to choose split notifications. OCI monitoring does not support the suppression of a specific resource in a grouped notification. As a result, split notifications will ensure compatibility between monitoring templates and maintenance windows, until support for suppressing specific resources is included in a grouped notification and allowed. This monitoring template is specific to production Oracle database hosts. Let's add a tag to support that. So Oracle Standard Environment Prod. Enable the alarms. All right, now with all of our fields complete, let's click Create. Fantastic. With our template now created, let's apply this to all of our production Oracle database hosts. That's it. We have successfully deployed our production Oracle database host monitoring template to all of our hosts that meet this requirement.
Wow, that was a really good demo, Aaron. I could see how that would definitely help with managing all of those alarm rules across systems. I'm wondering, though, as enterprises expand and they're going to end up with many alarm rules, when they do have to suppress alarms, as you kind of alluded to earlier, for example, they have to patch their database systems or maybe patch their host fleet, aren't they also going to have to figure out which set of alarm rules that they have to suppress? And won't that be a tedious task for them to do?
Absolutely. And that's what makes this next feature so exciting. Topology-aware maintenance windows. So we all know that resources need to be taken down for maintenance and for monitoring. This means temporarily suppressing notifications for alarms. This can currently be done by suppressing individual alarm rules. But when you have many alarm rules, it can become a challenge identifying the appropriate subset of alarm rules to suppress. So we've streamlined this essential monitoring task by providing a feature called maintenance windows that has a resource-oriented approach. When creating a maintenance window, users will specify their resources and the time of their window, and we'll take care of suppressing all of those relevant alarms. In this example, the user wants a maintenance window on host 2 and include all the resources that are running on that host. Stack monitoring will identify the corresponding alarm rules for those hosts and the resources running on those hosts and suppress them accordingly. So here's some examples of use cases that we support. Create a maintenance window for Friday at 6 p.m. for my hosts and all those resources that are running on it. Create a maintenance window for my EBS application, which includes all of EBS's components. Or maybe create a maintenance window on Monday at 10 p.m. for my database system. Or maybe, create a maintenance window on my Redis resources monitored by CollectD integration. So earlier we showed this same EBS suite topology. Now, instead of imagining creating alarm rules for every resource in this list, Now imagine needing to perform maintenance on this entire EBS application stack and having to manually identify every alarm rule associated with each of these resources and then create that suppression for each of those.
Wow, Aaron, that's a lot of work. I'm not sure I would even know where to start by trying to identify all of those relevant alarm rules.
And that's where you can simplify your maintenance activities with topology-aware maintenance windows. The task of determining the right appropriate set of relevant alarm rules for all resources in the maintenance window can be complicated and tedious. Eliminate this complexity by using maintenance windows. Maintenance windows can suppress alarm notifications for an entire fleet of hosts and all the resources running on those hosts, or suppress all alarm notifications for an entire application stack. It's application servers, databases, hosts, storage, load balancers, etc., in just a few clicks. For example, when performing maintenance on an Oracle database system, stack monitoring will leverage the topology to identify all the resources included in that stack. In the example here, we can see this Oracle database system contains a CDB, a PDB, and 2 listeners. Using this full list of resources, stack monitoring will identify every alarm rule related to each of these resources and suppress their notifications during the maintenance event. So by selecting this Oracle database system, stack monitoring will include these members of the database system in the maintenance event, removing the need for the engineer to identify all those alarm rules for all those resources that are impacted. This allows you to create a maintenance window based on the resource in maintenance, not each individual alarm rule for every resource. Now, maintenance events can occur at a moment's notice, or we would all prefer that they be well, scheduled well in advance. But this is where scheduling is critical, right? It's got to be flexible. Understanding the need, maintenance windows can be a one-time event that starts immediately, or it's in the future. If you have systems that need to be patched daily, weekly, maintenance windows can repeat on a schedule that meets your needs. Do you have a server that needs to be down for an extended period of time, or maybe just 15 minutes? Maintenance windows has those flexible options to meet those business requirements. Triaging open alarms can be overwhelming. And stack monitoring has already helped simplify this process by identifying open alarms that are included in an active maintenance window. So anywhere where you see alarm details in the stack monitoring UI, stack monitoring already provides, helpful information like that you would expect, right? Severity, trigger time, resource name, metric name, dimension like root, but where it really helps is current value. So you can see exactly root what its file system utilization is that's kicked off the alarm, right? Well, we've gone even further and ensured that any open alarm is identified with this wrench icon. That helps your engineers know that this alarm has been suppressed and is part of a maintenance event. When navigating to a resource's homepage that's part of an active maintenance window, stack monitoring will show a banner at the top of the page to inform the engineer the resources under a current maintenance window. It'll tell them when the event began, when the event ends. And additionally, there's a link that will take you directly to that maintenance window where the engineer can get more information about the event or to stop it. All right, so I've pre-recorded a demonstration on how to create a maintenance window. Let's take a quick look. For this demonstration, we will begin by navigating to maintenance windows. Maintenance windows allow you to suppress the notifications of open alarms. And from this screen, we can view all maintenance windows that are currently active, scheduled, and completed. In this example, we need to perform an immediate reboot of a host. We expect it to take about 30 minutes. And as a result, we will create a one-time maintenance window. From the maintenance window slide out, we'll enter a meaningful name and description. This will help educate the DevOps team if they see the open alarm in the console, what change is being made, and who's responsible for that change. So let's begin by providing a name and a description. And for this description, I've said we're doing an emergency reboot. It's on this host, on this date. I provided a link to the ticket of what's driving this change, as well as the change request number. The next step is to add the resource or resources involved in the maintenance window. To do so, I need to select our host here. But not all the resources that are running on the host, just simply the host itself. This is where the benefits of that topology awareness really shine. Instead of first identifying every resource running on the host, and then coming here and identifying every single alarm definition for each of those resources, right? Availability alarms alone is quite a few. If you start looking at the host, all the different WebLogic servers, concurrent managers, etc., there's quite a few alarm definitions that you need to suppress. But maintenance windows place the focus instead on the resource that requires the maintenance. So we need to reboot the host EBS04A. So the first thing that we're going to do, let's come down here, we'll filter by host, and then we'll select EBS04A. Now, if we were performing a reboot on several hosts, we could select one or many hosts at this time. But with our host selected, we'll add this host to our maintenance window. So with the host selected and added to our maintenance window, Stack Monitoring has identified 9 additional resources that will be impacted by this reboot and included those here. So let's take a look. So here's our 9 resources. It has identified EBS itself, a pluggable database, concurrent processing node, concurrent processing, and several different WebLogic servers. And all of those have been included in this maintenance event. Scheduling. So as I mentioned earlier, this is an emergency patching event of this host. And as a result, this will not be repeated. However, if this had been, say, a daily or weekly patching event, we could define that here. So for daily, if we click daily, we could define what day this repeated event should start and what day it should end. We could start it, say, on December 1st and have that reoccurrence occur every day until December 30th, just as an example. But alternatively, we could schedule this to repeat, I don't know, every Tuesday and Thursday. But since this is not a repeating event, we'll go back, we'll select no. From here, we can choose to start this event at a later date and time. And from there, we can select the date, the time, and even leverage a time zone to help make scheduling easy. But we're going to do this event right now, so we'll select immediate. So we could say just run for 90 days. We could set a date and time in which we want this to end, but we know we have fairly good confidence this is going to be over in 30 minutes, and we can simply add that here. So with all the fields defined, it's now time to create our maintenance window. We're asked if we're certain that we wish to go ahead and create this. We do. And now our maintenance window is in the process of being created. Okay, fantastic. We can see that our maintenance window was successfully created. See our definition. currently is assigned to one resource that has those 9 included members that we reviewed earlier. Let's go back to Enterprise Summary. Take a look at our current open alarms. And here we see we have an open alarm for our EBS 04A, and that alarm is currently suppressed as this resource is currently under maintenance. We also see that we have some PDBs down here with various storage open alarms, and all of those, as well as EBS itself, all of their alarms are currently being suppressed. Okay, now let's take a look at OCI monitoring. We'll close this screen. We'll switch tabs. Now here's an example alarm of an EBS alert. Scrolling down, we can see that while it is in a firing status, we can look at the alarm suppression history and see that this has a suppression of emergency reboot, EBS 04A, and our date. So it helps you identify that this resource is being suppressed and it's part of a maintenance event. Now let's return to the presentation.
Wow, that's a really good demo, Aaron. I could see where, by placing the focus on the resources and by using topology, I can see where this will greatly help our users whenever they have to suppress their alarms during a maintenance event. So if our users are now super interested and they want to start using this feature, where do they get started?
Well, we have all kinds of ways to help folks get started. So you can start off with we have a bunch of just general specific ways to get started. You can subscribe via RSS to our observability and management blog, where we frequently publish topics covering application performance monitoring, database management and monitoring, logging, and complete stack monitoring, and more. You can find us on X. Look us up on LinkedIn, where we have a bunch of additional learning opportunities. However, if you want to know about some specific topics around items that we discussed today, some features that we discussed today, simply follow the QR code. The QR code provides a link to our doc, release notes, blogs, pricing, and our live labs. Stack Monitoring Live Labs provides you access to try out stack monitoring in my demo environment that you saw here today. But that's what I have. Thanks for joining us. Thank you, Anna and Srini, and Catherine, who helped make this presentation possible.
There are a few series that you see on the slide. So these are the different Day 1 and Beyond series that you can visit and register for the upcoming sessions. We keep adding new sessions on trending topics on a regular basis. Yes, we are wrapping up this year with a couple of sessions in December, and then we'll come up with brand new sessions in January 2025. So you can go to any of these links and you can find these sessions over there on that page. And we'll share the link in an email that you'll get after the session.
Thank you so much. We appreciate everybody being here.
Thank you so much for joining this session. Really appreciate your time and your patience with everything, presenters and panelists. I'm sure everyone had a good learning experience over here. So anyway, so now it's a good time to talk about the next session. That is actually tomorrow. It'll be the topic for tomorrow's session is Oracle Cloud Networking Quick Start. In this session, you'll be introduced to core OCI networking services, how to deploy them, and best practices considerations for when and why to use these services. And with that, thank you so much for joining us. Thanks again, Aaron and Anna, for a great presentation. Have a good day, everyone.